All right, so today's unit we are looking at is exponents, and we're starting off the unit by looking at positive and negative exponents. All right, so when do we use exponents? So they're used when a factor is repeated more than once. So this exponent here, in this example, we have 4 as our base, and the 2 is the exponent. So that exponent tells you how many times you're going to write out the base to get your standard form or the answer. So this is the exponential form. We have our base, we have the exponent. The factored form of this, 4 squared, or 4 to the power of 2, the factored form would look like 4 times 4. All right, you are multiplying the base to itself 2 times, and then 4 times 4 is 16. So that's our factored form. 16 is the answer, or the standard form. So over here, we have 7 to the power of 3. 3 is the exponent, the base is 7. You may have seen this also called 7 cubed. So anytime you see the power of 3, it's also called cubed. But we would also say 7 to the power of 3. Factored form of that would be 7 times 7 times 7. The answer to that, or the standard form of that, would be 343. All right, so next we are looking at, sorry. All right, so we're going to look at these examples today. These are the ones with positive exponents. So what we'll do first is we are going to write them into standard form, and then we're going to get our answer. So here we have 7 to the power of 4. So that means we're multiplying 7, which is our base. We're multiplying it to itself 4 times. All right, so 7 times 7 times 7 times 7, and I've already showed you how to put that into your calculator. So 7 to the power of 4, and you should get your answer, 2,401. All right, so the next one we have is a fraction with a positive exponent. So writing this out in standard form, 2 over 3 times 2 over 3 times 2 over 3. All right, and we can multiply out our numerators here, 2 times 2 times 2, which gives me an 8. And then I'm just going to multiply the denominators, 3 times 3 times 3, which is 27. So for that, I get 8 over 27. All right, so for our next example, we have 3.5 to the power of 3. So that just means we're taking 3.5 times 3.5 times 3.5. All right, so just put that into your calculator and you should end up with 42.875. So the next one we have is 5 to the power of 0, and that is equal to 1. So if you try that in your calculator, any number, or if you had a letter, such as a variable, if it had an exponent of 0, it will always be equal to 1. All right, so try that in your calculator. So just to reiterate that about a power of 0 or an exponent of 0, it will always be equal to 1. So we can write that as if we had x to the power of 0, x can be anything, we can put anything here for x, it will equal to 1. All right, so next we have negative 5 in brackets to the power of 4. So when we look at this one, that means it is negative 5 times negative 5 times negative 5 times negative 5, and our answer will be positive. All right, we have an even number of negative numbers, being multiplied together. So therefore our answer will be positive, and it's a positive 625. All right, so example number 5 is very similar to example number 4. Example number 4 had brackets. Example number 5, there are no brackets. So when we're doing an example like this, the negative stays on the outside. Think of it as a negative 1. And then we have 5 times 5 times 5 times 5. And we will end up with a negative 625. So brackets make a real difference here when working with exponents. Okay, so next we are looking at negative exponents. So whenever we have a negative exponent, we are going to take the reciprocal of the base. And then once we take the reciprocal of the base, we can change the negative exponent to a positive exponent. And once we're back to a positive exponent, then we're going to work with it the same way that we've been doing before. Okay, so let's take a look here at these examples. So here we have our base is 5, our exponent is negative 2. So the rule with negative exponents is we are going to take the reciprocal of 5. So the reciprocal of 5 becomes 1 over 5. All right, once you've taken the reciprocal, this negative exponent now becomes a positive exponent. So it becomes 1 over 5 to the exponent, or to the power of 2. All right, and now we can write that in factored form. So 1 over 5 times 1 over 5, which gives me 1 over 25. All right, let's try this next one here. Our base of 4, our exponent is negative 3. So the reciprocal of 4 is 1 over 4. So this will become 1 over 4, and now our exponent becomes positive. Okay, so factored form of 1 over 4 to the power of 3. So we write that out as 1 over 4 times 1 over 4 times 1 over 4. And we would just multiply that out. Our numerator would just be 1. And then 4 times 4 times 4, which is 64. All right, let's try number 3. Again, our base is 3 over 4. Our exponent is negative. It's a negative 3. All right, so we have to take the reciprocal of our base. So 3 over 4, we're going to flip that. It becomes 4 over 3. And now our exponent becomes positive. So factored form, that becomes 4 over 3 times 4 over 3 times 4 over 3. All right, multiply the numerator. 4 times 4 times 4, which is 64. 3 times 3 times 3, which is 27. Our next example, we have in brackets, we have negative 3 over 4. So we're taking the reciprocal of it. So it's just going to become negative 4 over 3. All right, and now our exponent is positive 3. And now we're just going to write it out in factored form. So the negative is included in the brackets. So negative 4 over 3 times negative 4 over 3 times negative 4 over 3. Okay, we have an odd number of negatives, so our answer here will be negative. 4 times 4 times 4, which is 64, and then 3 times 3 times 3, which is 27. All right, so our last example here, so in brackets we have negative 5, that's our base, our exponent is negative 4, So we do have to flip this. So it's going to become negative 1 over 5 to the power of 4. Okay, and writing this out, our negative is inside the brackets. So negative 1 over 5 times negative 1 over 5 times negative 1 over 5 times negative 1 over 5. All right, and that's going to give me 1 positive. It is going to be a positive answer. And then 5 times 5 times 5 times 5, which is 625. So next we're looking at how exponents are also used to represent numbers in expanded form. So let's take a look at these examples. We're going to put these into expanded form. All right, so we have 4 in the hundreds place. So we can write that as 4 times 10 to the power of 2. Then we have our 2 in the tens place. So that becomes 2 times 10 to the power of 1. Then we have 8 in the ones place. In our ones place, we have to use our exponent of 0. So it becomes 8 times 10 to the power of 0. We have 5 in the tenths place. So that becomes 5 times 10 to the power of negative 1. And then we have 6 in the hundredths place. So that becomes 6 times 10 to the power of negative 2. All right, so that is how we would write numbers in expanded notation using exponents. All right, so our next example here, we have 6 in the 10,000s place. So when we write this out, that becomes 6 times 10 to the power of 4 plus, now we have 9, oh wait, we have 7 in the thousands place. So 7 times 10 to the power of 3 plus, then we have 9 times 10 to the power of negative 1 plus 5 times 10 to the power of negative 3. All right, so I'm just going to continue with the last one here. We have 5 in the thousands place. So that becomes 5 times 10 to the power of 3 plus, we have 6 in the ones position there. So 6 times 10 to the power of 0. That's a 0. And then we have 8 in the hundredths place. So 8 times 10 to the power of negative 2. All right, and we don't have to include those zeros. All right, so for these examples, we have to find the missing exponent e, or we have to find the base b in each question here. So 2 to the power of e. So that means we have a base of 2, and which exponent will give me 128? All right, so we came up with the answer here was 8. It's 2 to the power of 8 is equal to 128. So therefore, we can just say the e was equal to 8. All right, b squared. So we have to figure out what the base is. The base squared gives me 1,764. All right, and using guess and check, it's 42 squared, which gives me 1,764. So therefore, we can say that the b is equal to 42. All right, here, 6 to the power of e is equal to 216. So we know like 6 squared, or 6 to the power of 2 is equal to 36. So keep going. So we get 6 to the power of 3 is equal to 216. So we can say e is equal to 3. And the last one, A base to the power of 4 is equal to 81. And in that one again, so guess and check. The base is equal to 3. So 3 to the power of 4 gives me 81. So therefore we can say our base was equal to 3. All right, so lastly, we're given an expanded form and we have to put it into the standard form, or just the standard numeral for each of the following. All right, so these ones we are writing the standard numeral. So we have 5 times 10 to the power of 4. That's in our 10,000s place. All right, and then we have 3 times 10 to the power of 0. That's going to be in our ones position. So I'm just going to put out our positions here. Okay, so we can fill in our zeros. And then we have 3 in the ones position. So right there. And then we have 6 in the 10th position. All right, so just rewriting that out, it's 50,000, 3.6. All right, our next one, we have 3 in the hundreds position. So I'm just gonna put out our positions here like so. All right, so we have 3 in the hundreds position. We have 6 in the tens position, nothing or 0 in the ones position, and then we have 6 in the tenths position. All right, so 360.6.